The world is changing. We are moving towards a future powered by renewable energy. The sun and the wind offer us clean and sustainable alternatives. But these sources are intermittent. They require a way to store energy for when the sun isn't shining or the wind isn't blowing. This is where battery energy storage systems, or BESS, come in. BESS are like giant batteries, storing energy from renewables and releasing it when needed. They are essential for a reliable and sustainable energy grid. BESS are becoming increasingly important in our transition to a cleaner future. They are key to unlocking the full potential of renewable energy sources. Imagine a world where the lights never go out, powered by the sun even at night. This is the promise of BESS. The journey of a battery energy storage system, or BESS, begins with the smallest yet most crucial unit, the battery cell. These tiny powerhouses are the building blocks of the entire system. These cells are where the magic of energy storage happens. They are meticulously crafted to ensure efficiency and reliability. The process starts with the manufacture of electrodes. These are essential components that play a critical role in the cell's ability to store and release energy. These electrodes are like the positive and negative terminals of a battery. They are the points where energy enters and exits the cell. They are coated with special materials that can store and release energy. This coating process is vital as it determines the cell's capacity and efficiency. The electrodes are then stacked together with a separator in between. This precise stacking ensures that the cell functions correctly. This separator prevents short circuits by keeping the positive and negative electrodes from touching each other, which is crucial for safety. The entire assembly is then carefully placed into a pouch or a cylindrical casing. This casing protects the internal components and maintains the cell's structural integrity. Electrolyte, a liquid or gel that conducts ions, is then filled into the cell. This substance is essential for the movement of ions between the electrodes. This electrolyte allows the flow of energy within the cell, enabling it to charge and discharge effectively. Finally, the cell undergoes a process called formation and aging. This step is crucial as it stabilizes the cell's chemistry and prepares it for real-world use. This prepares the cell for its first charge and discharge cycle, ensuring optimal performance. Each cell is tested rigorously to meet high standards of quality and reliability before it becomes part of a larger energy storage system. Individual battery cells, while powerful, are not enough to power a city. To create larger energy storage units, multiple cells are connected together. This forms a battery module. It's like connecting multiple small batteries in series and parallel to increase the voltage and capacity. The assembly of battery modules is a precise and delicate process. Cells are connected using conductive materials. Sensors are integrated to monitor temperature and voltage, ensuring the module's health. Safety devices like fuses and thermal interrupt devices are also incorporated to prevent overcharging, overheating, and potential hazards. The entire module is then encased in a robust housing, providing physical protection and insulation. The journey from individual cells to a complete energy storage system continues with the meticulous creation of battery packs. This process is crucial for ensuring that the energy storage system is both efficient and reliable. Multiple battery modules are carefully grouped and connected together. Each module is a vital component, and their precise connection is essential for the overall performance of the battery pack. This forms a battery pack, which is a substantial and powerful energy storage unit. These packs are designed to store and deliver energy efficiently, making them integral to various applications. It's similar to combining multiple battery packs in your electronic devices to get more power. By increasing the number of modules, the capacity and power output of the battery pack are significantly enhanced. The process involves carefully connecting the modules using specialized tools and techniques. This ensures that each connection is secure and capable of handling the electrical load. This ensures proper voltage and capacity distribution across the entire battery pack. Rigorous testing is conducted to verify that each module is functioning correctly and that the pack meets all performance standards. A battery management system, or BMS, is then integrated into the battery pack. This system is crucial for maintaining the health and efficiency of the battery. The BMS acts as the brain of the battery pack, constantly monitoring and managing its performance. It collects data from each cell and module to ensure everything is operating smoothly. It monitors the health and performance of each cell and module, providing real-time data and alerts if any issues arise. This proactive monitoring helps in maintaining the longevity of the battery pack. It also manages the charging and discharging process, ensuring safety and longevity. By controlling these processes, the BMS helps prevent overcharging and deep discharging, which can damage the battery. Thermal management systems, like cooling fans or liquid cooling plates, are also incorporated into the battery pack. These systems are essential for maintaining the optimal temperature of the battery. This regulates the temperature of the battery pack, preventing overheating and ensuring optimal performance. Effective thermal management is key to the safety and efficiency of the battery pack, allowing it to operate under various conditions without risk of failure. Section 5. Bridging the gap power conversion systems. In this section, we delve into the crucial role these systems play in modern energy management. The energy stored in a battery pack exists as direct current, or DC. This form of electricity is essential for storing energy efficiently. However, the electricity grid and most appliances use alternating current, or AC. This discrepancy necessitates a reliable method to convert between these two forms of electricity. This is where power conversion systems come in. They serve as the bridge between the stored energy in batteries and the usable energy for our homes and industries. These systems, consisting of inverters and converters, act as translators between the battery pack and the grid. They ensure that the energy can be used effectively and safely. The manufacturing of power conversion systems involves intricate electronics and control systems. Each component must be precisely engineered to handle the complex task of energy conversion. Inverters convert the DC power from the battery pack to AC power for grid usage. This conversion is vital for integrating renewable energy sources into the existing power infrastructure. Converters, on the other hand, transform AC power from the grid to DC power to charge the battery pack. This process ensures that batteries are always ready to supply power when needed. These systems are integrated with sophisticated control systems. These controls monitor and manage the flow of electricity, ensuring optimal performance and safety. These systems ensure the efficient and safe operation of the BESS, synchronizing it with the grid and managing power flow. This synchronization is crucial for maintaining a stable and reliable power supply. Section 6. A secure shell housing the BESS. With the battery pack and power conversion systems ready, the next step is to house them safely and securely. This is where containerization or specialized structures come in. These enclosures provide protection from the elements and ensure the safe operation of the BESS. The assembly process involves integrating the battery packs, power conversion systems, and other components into a container or a dedicated structure. These enclosures are equipped with fire suppression systems, HVAC systems for climate control, and safety features like emergency shutdown buttons. The containerization process ensures that the BESS can be deployed in various environments, from urban settings to remote areas. Section 7. The conductor's baton control and monitoring systems. The complexity of a BESS requires a sophisticated conductor, the control and monitoring system. This system acts as the brain of the entire operation, ensuring the BESS operates safely and efficiently. It monitors every aspect of the system, from the health of individual cells to the power flow between the BESS and the grid. The manufacturing of control and monitoring systems involves both hardware and software development. Supervisory control and data acquisition systems, programmable logic controllers, and other hardware components are manufactured to collect and transmit data. Software engineers develop sophisticated algorithms and user interfaces. These allow operators to monitor the BESS, analyze performance data, and control its operation remotely. Section 8. Ensuring excellence testing and quality control. Before a BESS is deployed, it undergoes rigorous testing and quality control procedures. This ensures that it meets the highest standards of performance, safety, and reliability. These tests simulate real-world operating conditions, pushing the BESS to its limits to identify any potential issues. The testing process involves evaluating the BESS's performance under various load conditions, temperatures, and charge-discharge cycles. Safety features are rigorously tested to ensure they function flawlessly in case of emergencies. Quality control measures are implemented at every stage of the manufacturing process. This ensures that only the highest quality components and workmanship go into the final product. Section 9. BESS, a sustainable future. The intricate process of manufacturing BESS, from tiny cells to massive containers, is a testament to human ingenuity. These systems are paving the way for a future powered by clean, renewable energy. They are essential for mitigating climate change, reducing our reliance on fossil fuels, and creating a more sustainable future. BESS represent a significant step forward in our quest for energy independence and a healthier planet. As we continue to innovate and improve these systems, they will play an increasingly vital role in our lives, powering our homes, businesses, and transportation systems. Section 10. Looking ahead. Advancements in BESS technology. The world of BESS is constantly evolving. Researchers and engineers are constantly working to improve the efficiency, cost-effectiveness, and lifespan of these systems. New battery chemistries, advanced materials, and innovative manufacturing techniques are constantly being developed. The future of BESS is bright. As technology advances, we can expect to see even more powerful, compact, and affordable energy storage solutions. These advancements will further accelerate the adoption of renewable energy sources, bringing us closer to a cleaner, more sustainable future.